So welcome. So now we discuss radioactive losses. So radiative losses occurs whenever an optical fiber undergoes a bend of a finite radius of curvature. Fibers can be subjected to types of bend. Macroscopic bends having a radii that are large compared to the fiber diameter. Random microscopic bend of the fiber axis that can arise when the fibers are incorporated into cables. So let us examine the large curvature radiation losses, which are known as the macro banding losses. For slight bend, the excess losses are extremely small and is essentially unobservable. So as the radius of curvature decreases, the losses increases exponentially until at a certain critical radius of the curvature loss becomes observable. So a sharp bend in the fiber can be causes significant losses as well as the possibility of mechanical failure. So the ray safely outside the critical angle and it's therefore the propagated correctly. So now if the core bends, then see the diagram. Now it's the core bends, the normal will flow it the ray. So will now find itself on the wrong side of the critical angle and will escape. So the tighter the bend cause the worse the losses. Therefore the critical radius determined by the attached instruments indicated loss of over 6 decibel. So if a bending radius is smaller than the critical radius cause the damage in optical fiber. And then the macroscopic bends, so the macroscopic bends, the radius of core is large compared to the fiber diameter. It is may causes large curvature at the position, so where the fiber cable turns at the corner. So at these corners, the light will not satisfy the conditions for total internal reflection, and hence the escape out from the fiber. So this is called as the macroscopic or macro bending losses. Also note that the losses are negligible in small bends. And micro bends losses caused due to the non uniformities or micro bends inside the fiber as in shown. The micro bends in the fiber appears due to the non-uniform pressures created during the cabling of the fiber or even during the manufacturing itself. This lead to loss light by the leakage through the fiber. So the remedy of these losses, the micro bend losses can be minimized, extracting sneezing out and compressible jacket over the fiber. So in such cases, even when the external forces are applied, the jacket will be deformed, but the fiber will not tend to stay relatively straight and safe, so without causing more loss. And one more thing, so already when the radial loss occurs of fibers due to the bending finite radius of curvature, and scattering also wavelength depend on the loss, so which occurs inside the fiber. Since the glass is used fabrications of fiber, the disordered structure of glass will make some variations in the refractive index inside the fiber. As a result, if light is passed through the atoms in the fiber, the portions of light is scattered. That means elastic scattering. So that is the type of scattering is the Lorentz scattering. And so when light propagates through an optical fiber, small percentage of light is lost through the different mechanisms. The loss of optical fiber measured in the decibels per kilometers for attendance losses, and is the more important of radiative losses is due to the presence of macroscopic and microscopic bands in the fiber. Thank you.